Section E, where functions meet. In this section, we're going to consider quadratic function and a linear function and how they can intersect each other. One way is they can be cutting each other, and that's where they'll have two intersection points. The linear function cuts the quadratic function. To figure that, we'll just set the quadratic equation equal to the linear equation and solve for x. We should get two answers. Touches is where they only have one point of intersection. We do this the same method. We're going to set the quadratic equation equal to the linear equation and solve. We should only get one answer. And the resulting quadratic equation that you should get, because there's only one answer, that means our determinant must be equal to 0. That'll give us the one answer. The last possibility we can have is missing. That's where when we set the quadratic equation equal to a linear equation and solve for x, we get a no solution situation, or an I, or imaginary numbers. So again, when you're having quadratic and a linear function intersect, if they are cutting each other, if they're touching each other, there'll be one solution. If they're cutting each other, there'll be two solutions. If they're missing, there'll be no solution to your equation. Example number 1. Find the coordinates of the point of intersection of the graphs of the equation of these two equations. So we're looking at first equation is the quadratic, x squared minus x minus 18. Second equation is linear function. So to do this, again, just set the quadratic equation equal to the linear function. Since they're both equal y, we can substitute y, x minus 3 in place of the y. Now to solve this equation, since there's a quadratic, there's an x squared, we got to get it equal to 0. So we're going to move all our terms onto one side of the equation, combine like terms, and solve the resulting quadratic. So I'll factor this one. Use our null factor rule, and we find that x will equal 5, or x would equal negative 3. Now it asks us in the directions to find the point of intersection. So the point means I need an x value and a y value. So now I got to figure out how to find my y values. Well, to find the y values, you just substitute in the x solution into either equation. Doesn't matter which one. I'm going to choose the linear because it's a little bit easier to work with in this situation. So when x equals 5, my y is 2. So therefore, one point of intersection is the point 5, 2. To find the second point of intersection, I'm going to replace x with negative 3. So when x is negative 3, then y would be equal to negative 3 minus 3, or y equals negative 6. So our second point of intersection is the point negative 3, negative 6. You've solved your first intersection equation. Example number 2. This time they're asked us just to solve for x. I'm going to do part A two ways. I'm going to do it without technology, then with technology to see how you can use your calculators. So I want to know when x squared plus 5x plus 6 is equal to 2x squared plus 2x minus 4. And this time all I have to do is figure out the x. So again, I'm going to get it equal to 0. So I'm subtracting the left-hand side from the right-hand side, combining like terms, factoring if possible, or solving the quadratic, I will factor. Then use the zero product rule and set each factor equal to 0 and solve. I get that x is equal to 5 or x is equal to negative 2. Since it only asks us to solve for x, we're done. Now, how would I do this if I wanted to use my technology or my calculator? So you go to your y equals screen, you plug in the first equation into y1, then curse it down and plug in the second equation into y2. We'll start with the standard screen. Now we're looking at when they equal each other would be when the two graphs intersect. So we're looking for the intersection points. Okay, I can only see one intersection point. I have another one up here, so that means I need to go to my window, and I need to go higher up on the y-axis. I'm going to change my y-max. And since I've got 70 points here, I'm going to count by tens. Okay, I can see the two intersection points, but that one is so close to the top, I like to give myself a little bit more lead room, so I'm going to go up a little bit higher on my y-max. There, that's better. I can distinctly see the two intersection points. Now, to find that in your calculator, you go to your calculate button, which is second trace, down to number 5, which is intersection. push enter. Now first curve, you move it close to the intersection point you're looking for, then push enter. You don't want it on it, but you want it close to it. And then just enter 2 more times, and it shows me my intersection point is -2, 0, which matches what I found algebraically. I'm going to repeat this, so second trace, intersection number 5, move cursor to the other intersection point. Now again, I'm going to get close to it. Well, I'm closer to that intersection point than the other, but I do not want on top of it. Enter, enter, enter. And then I get x equals 5. So the 5 and the -2 is what we found algebraically. Now let's look at part B. We're going to do part B with calculator. So I want to figure out when x squared plus 5x plus 6 is greater than 2x squared plus 2x minus 4. This equation to 2 equations. So I have the first inequality is greater than y. I'm going to flip that over, and I got y is less than x squared plus 5x plus 6. And I'm going to make that my y1. I'm doing my calculator. And now here, I'm going to have y is greater than 2x squared plus 2x minus 4. So it's the opposite of what we did when we solved it. We're splitting it up. Now I'm going to use the inequality notation in my y equals function. So I'm going to put in y1, I'm going to have the less than 2x plus 5x plus 6. And the less than button looks like a little downward arrow. And I'm going to do the greater than button. And on the greater than button in your calculator, it looks like a kind of upward little slant arrow going up. So let's look at our calculators. So we still have the 2 functions in here in our y1, y2. So all I'm going to do is cursor over here. So I'm highlighting that sign, the letter, the color in the symbol, and I'm going to cursor left until I get to the less than symbol. And then I'm going to push enter twice. Cursor down to y2, and I'm going to push enter, enter, and cursor down to the greater than symbol, and then push enter, enter. Now, what I'm looking for in this graph is I want to put where the 2 shaded regions intersect. So when the red graph and the blue graph intersect. I'm kind of making a little bit more. You can see this purple color here. That's the intersection point. And I only want the x values in which they intersect. So I'm going to find those 2 intersection points, which we found in the last problem. And to find those intersection points, you do the exact same thing as we did in the last problem. So I'm going to skip that. And they intersected at -2 and 5. So my answer here is I want all x values between -2 and 5. And I'm going to say -2 is less than x, which is less than 5. I'm not going to use the less than or equal to because my original equation was just a less than, and there was no equal to sign. And that is all you do for using your calculator to graph these quadratics. Example 3. This time we're going to look at this linear equation is tangent to the quadratic equation. We're going to find k. So you set it up the same way, but the word was tangent. Tangent means that they meet at one spot. So this is where they just touch each other. And so I should have one solution to my problem. So we're going to set it up. I'm going to do the quadratic first. So I'm going to say the quadratic equation, 2x squared minus 3x plus 4 is equal to 2x plus k. As always, I need to get it equal to 0, so I'm going to subtract the 2x and then subtract the k, combine like terms. I'm going to put this 4 minus k together because that's my entire constant. Because that k is some number, I just don't know what the number is. Now this equation only has one solution, so that means the determinant has to be equal to 0. So I'm going to find the determinant of this expression. Remember, the determinant is b squared minus 4ac. So that's going to be -5 squared minus 4 times 2 times 4 minus k. Simplifying this expression down. Now remember, determinant should equal 0, so I'm going to place my determinant symbol with 0. And then I'm going to solve this little equation for k by adding 7 to each side, then dividing by 8. So I've finished this problem. K is equal to 7/8.